what is the definition for wave?
It's a disturbance that can transfer information and energy.
So it's a disturbance. Okay, very good. So there are how many types of wave you think?
2.
Okay, write it down. Write down in like a table chart.
I forgot both of them.
All right. So mechanical wave
and electromagnetic wave.
So mechanical wave. Okay, write it down. Mechanical wave. And electromagnetic waves. All right, now, very good. All right, so what is the difference between mechanical waves and electromagnetic waves?
Electromagnetic waves need a medium to travel through, but mechanical waves don't.
It's the opposite. It's the opposite. Yeah. Mechanical wave mechanical wave do not need any medium to travel. However, mechanical wave do need. Mechanical waves do need medium to travel. Electromagnetic wave do not need medium to travel. There are how many kind of mechanical waves?
I don't
2.
know.
Transversal wave, write it down. Make sure you leave enough space.
Yeah.
Transversal wave, and the other one is longitudinal wave. Longitudinal wave. What is the definition for transversal wave? Can you draw in a wave? Here, can you draw a wave in the middle of that?
Oh, you get of this?
Yeah, draw a transversal wave.
Okay.
Alright, first you have to draw the axis. Alright, so this is x and this is y. So, okay? So transversal wave means the disturbance that that initially took place, right? So this is the medium, right? This is the medium. Think as if this is a medium, right? So the particles of the medium oscillating perpendicular, the particle of the medium oscillating perpendicular to the direction
Of its
of the energy that wave is transferring. Is it complicated? Maybe. Can you say it?
so it's oscillating.
The particles of the medium. What is the particles of the medium? Is this a medium?
No.
This is a medium. I created a sound wave. As soon as I assaulted this chair, I created a sound wave. This sound wave traveled through the medium.
Yeah.
Yes. So is this a medium?
Yeah.
Is this a medium?
Yeah.
Are you the medium?
No.
Yes.
But I don't. But you didn't create a sound wave, right?
So not sound wave. Is there only sound wave in the universe? If I put an X-ray over here, X-ray is going to go through your body.
Yeah.
Obviously, it's going to take the picture of your bone. All right. So are you a medium?
Yeah.
Is this guy a medium?
Yeah.
Is this guy a medium?
Yeah.
Obviously, yeah. If it's not one kind of medium, then it is other kind of medium. Everything is medium, okay? So medium is made of what? Atoms.
Yeah.
What do you have inside the atom? Tiny particles.
Yeah.
So those particles are not moving or moving? When you assault something, those particles are moving or not moving?
They don't go in the direction.
No, I'm asking you, they're moving or not moving?
They move up and down.
They're oscillating or not oscillating?
oscillating.
They are oscillating, right? They are oscillating perpendicular to the direction of the energy due to the wave. Does it make sense?
Yeah, I can.
Well, okay, so it will make sense soon. Now, how can you measure the wavelength? What do you call this guy? Crest.
Crest.
What do you call this guy? Trough. Alright?
Yeah.
So, what is a wavelength?
The distance from the crest to the trough.
No.
It's from here to here.
From here to here is a wavelength, or crest to crest is a wavelength. Wavelength is lambda. Or trap to trap is a wavelength. Or this guy to this guy is a wavelength. You understand? You know, at the same point to same point, but we're not going to confuse ourselves. We're going to say crest to crest is a wavelength, or trap to trap is a wavelength. We're not going to take the things apart, okay? What is the amplitude?
It's
The peak, the highest point from the center.
Yeah.
Alright? The place when the things like changes the direction. If I toss a chalk, what happened?
There is the point where it changes the direction.
What would be the velocity of that point?
0.
Okay, good. So what is the velocity right here?
0.
So the velocity is 0 means from the center to that guy is amplitude. Next come period. What is period? Well, before period, let's talk about frequency. What is frequency? So now a wave has many properties. A wave has crest, a wave has trough, right? Crest is the highest point, trough is the lowest. A wave has an amplitude, and now we know a wave has a frequency. What is frequency?
How often the wave oscillates?
How often a wave completes its cycle in 1 second. That's the definition. How often a wavelength completes its cycle in 1 second. Okay. So if I have a slinky, if I do it like this, it's gonna be more frequency, or if I do it like this, it's gonna be more frequency.
If you do it fast.
Level, right?
Yeah.
What is? Can you write down the F for frequency? F for frequency.
Here.
Yep. So what is the formula for frequency? 1/T.
And T.
1/T. Right. 1/T.
And T is time in second.
T is time in second. Okay, that's it. One wave, right? No, or the wave per second. The wave per second. We are not talking about how many waves. Wave per second. Wave per 1 second. All right. Now, period. That comes period. Frequency and period, they are like two sides of the same coin. So period we call what? Guess what is the symbol for period? P for period?
No. First. No.
T for period, right? T. Big T. Is this a big T?
Oh.
Okay. So inverse. Period is inverse of frequency. So how can you write that?
That would be T.
1/F.
Oh. Oh, it's just this. Right?
Yeah, 1/F.
Oh.
Okay, so now if I tell that there are 3 waves, the frequency is 3 waves per second, what would be the period?
The frequency was.
If the frequency is 3 waves per second, what would be the period?
So if F was 3.
Frequency is 3 waves per second. Frequency is 3 waves per second. What would be the period? F, right F. No, right F. Or 3, right 3. 3 waves per second, yep. What would be the period?
Well, it would be whatever T is to give to make F3.
Cross multiply. If you don't get it, cross multiply.
So,
no, that's not how you cross multiply. Okay, 3t equal to, okay, 3t equal to?
1.
So t equal to?
So T equals to 1/3 of a second.
So that means what? Every wavelength take
1/3 of a second.
and 1/3 of a second, how much? About 0.33, right?
Yeah.
0.33 second. Does it make sense? If I tell you 2 waves per second, frequency is 2 waves per second, what is the period?
Half a second.
It takes half a second for one wave to finish it. What?
Whole
Second.
second. Yeah.
Now we don't call it, what is the as a unit for frequency?
Second.
No, period is second.
Oh.
Period is
Second.
second. What is the frequency? Hertz.
Oh.
Hertz. You probably heard that.
Yeah.
Unit, right? Hertz is after a scientist name is Heinrich Hertz. What is the human? How loud human ear can handle?
I think 100 in what?
From 20 decibel to 2000 decibel, but that's not what we're doing. Alright, now what do we learn? Did you learn wavelength?
Yeah.
What is wavelength?
It's the distance from any 2 points.
Tell me the easy one.
Okay.
Distance between crest to crest?
Yeah.
Or?
From sharp to sharp.
Okay. Something else we don't need to know. What is the amplitude?
It's the distance from the center to the crest or trough.
No, from center to the crest of top. Okay, very good. What would be the frequency?
1/T. That would be the.
1 over T. What would be the period?
1 over the frequency.
1 over F, right? Now, this comes to the velocity. Does it? Necessarily, right? The final part. Velocity. What do you think velocity would be?
Maybe the
Right velocity in classical mechanics. What is velocity? Distance over time. Now, in this case, what is distance? You just said distance is from crest to crest. What do you call that? Wavelength. So right wavelength. It is D, right wavelength. Very good. Lambda, not W. Alright, so lambda over T, right? So is it better to say 1 over T times lambda? Right, that right equal sign in the down, right? 1 over T times lambda. Nicely, right? Nicely. Other 1 over T lambda. Does it make sense? From that line to this line, does it make sense mathematically? You don't see that? You don't see how that happening?
Oh, you multiplied.
I didn't do anything. Lambda over T, right? What is T? T is what? T is upstairs or downstairs? Downstairs. What is then upstairs?
Lambda.
Lambda, right? Can we write? Can we separate lambda? Can we write lambda outside and write 1 over T?
Yeah.
Huh?
Yeah.
So why then it doesn't make sense?
Oh,
Hmm?
yeah, I get it.
Why did you do that? Is that you did it for fun?
You know what? Maybe you can substitute this
That's right. What do you substitute 1 over t?
1 over 1 over f.
1 over t is substitute to what? Not 1 over f. That's not what.
That's
What
just
was
f.
what? That's just f. It was okay. So f times lambda. So velocity is what?
The frequency times lambda.
Lambda. So is it classical mechanics? Yeah. I mean, you know, isn't it? We just have to do some algebra. But if you like, you know, when you see it first glance, classical mechanics tell d over t and it says f over lambda. It seems like there is no relation, right? It seems like there is no similarity between two, except like this term is b, this term is b, right?
Yeah.
But do you see the algebraic relationship? Did you establish the algebraic relationship or not? Or did you not?
Yeah, I know. I see the relationship. So we just replace the d and the t with whatever the
Why wavelength is d? We understand that?
yeah.
Why 1 over t is frequency? Did we establish that? So now can we say that the same thing? It's not same thing, but it's similar?
Yeah, well, this is same. This is identical to d over t, right?
Mm-hmm. Oh. Now if f is, what is f?
1 over t.
We know that f is what? We just did that. F is 3. Okay, say now if the lambda is, okay, if it takes from here to here 2 meters and frequency is 3, as you said, hertz,
Yeah.
what would be the velocity?
6 hertz
Do that.
per
Do
hertz.
that.
Okay.
3 hertz. Frequency is 3 hertz. 3 hertz, by the way, 1 over second. When you do math, you write 1 over second, not 3 hertz. Write 1 over second. 3 hertz is 1 over second times meter. Okay, very good. Now what is this? 6 meter per second. Okay? Alright. Is this the classical mechanics also meter per second?
Yeah.
Okay, now you say yes, this is meter per second. What have we been doing now so far? We have been doing transversal wave, right?
Yeah.
We spent half an hour for transversal wave, right?
Yeah.
Okay, can you erase transversal wave? Now we're going to do longitudinal wave.
Well, all the attributes are same, right?
No. If it was saying that, can you give me an example of transversal wave? All the lights were transversal wave. When you throw a pebble on the pond that makes a ripple,
Yeah.
that's transversal wave. But longitudinal wave is different and is very difficult to visualize. You know what I mean?
Oh yeah, it's very very high frequency, right?
Alright, so longitudinal wave is like that. So, have you ever seen Slinky?
Yeah.
So, okay? We buy Slinky and oh, okay. Alright, thank you. Eva, turn it off. Turn it off.
Oh.
Hello?